This is 7-5, day number 2. In day number 1, I mentioned that with tangent, cotangent, cosecant, and secant, we have to pay attention to where those are undefined. With sine and cosine, those two ratios are y over r and x over r respectively. And we know, if we think about an angle that's formed on a coordinate grid, r can never be 0. So we never had to think about the case where they're undefined. The other 4, which have x or y on the bottom, are not this way. Those could be. So let's take a look in terms of angles when tangent would be undefined, keeping in mind that tangent is y over x. So the question ultimately becomes, on our unit circle, where is the x-coordinate 0? And that takes place at 2 points, at pi over 2. I'm going to put both units, or 90 degrees, and at 3 pi over 2, or 270 degrees. Okay, again, those are the 2 points because the x-coordinate is 0. That's where tangent's undefined. Now let's actually jump down here to secant, because even though secant is x over r, it still has x on the bottom. So all I'm going to put here in my notes is secant is just simply the same as tangent, because they are both over x. Let's jump back over to cotangent. This is now a different story as it's x over y. Here and here, those are the 2 points in the unit circle where y is 0. So it would be 0, that could be radians or degrees. And then at pi radians, or 180 degrees, that is where cotangent is undefined. And now for the exact same reasons, I'm going to hop up to cosecant. Those same reasons being because it's over y, just like cotangent. And all I'm going to put there is the same as cotangent. So those take a little glimpse at where these 4 trig functions can potentially be undefined. And again, this is all coming back to when is it over 0. And these are the cases where that can happen. All right, one last example to look at here. We've done something kind of like this in the sense that we're evaluating. We're evaluating some trig functions. Before we saw an angle with a given sine or cosine value, and the objective was just to say, if we had sine, what's cosine? Okay? Well, this is going to look really similar, so it shouldn't seem brand new. But now we're going to do it for the other 5. Okay? And really what this comes down to is we need to know x, we need to know y, and we need to know r. And in fact, I'm going to start that off right here. X, y, and r. The information I'm given has 2 components. First of all, it tells me that the tangent of theta is negative 3 over 4. Now I'm considering here just the general tangent ratio, which is y over x. And this has a lot to do with these 2 numbers, as I'm essentially given x and y, and will only have to go to this graph to the right just to get r, because I've already got x and y. Okay. Now this doesn't mean that x is 4 and y is negative 3. In fact, I'm not going to write that yet, because it's possible the x coordinate of 4, that the negative sign goes with that. Okay, I'm not sure yet. That leads into this information that tells us this angle theta is between pi over 2 and pi. Well, pi over 2 is right here. Pi is right here. This is just a fancy way of telling us that our angle is in quadrant 2. Okay, so here's my initial side. Here's my terminal side. And now I'm going to draw in the right triangle that's formed by the reference angle. Okay, there it is. Now I got to think here about x and y. If I'm in quadrant 2, okay, I've already established I don't know r. X coordinates are negative, so this must be -4, and this must be +3. Okay, and now you might wonder for this tangent value, why wasn't it written like that? Well, when we have a fraction, okay, we typically always write the negative sign on the top. Okay, so you got to be careful. Just because it's written next to the 3 doesn't mean it goes with the 3. And in fact, here it doesn't. It goes with the 4. X is -4, y is -3. A little application of the Pythagorean Theorem will help me get r. You're going to see here that the numbers are going to come out very nice. This is a 3, 4, 5 triangle. 16 plus 9. R squared is 25, taking the square root. R is 5. And I'm only interested in the positive answer because R always has to be positive. Well, now I can just go ahead and move right along. And because I have X, I have Y, I have R. And really you're going to see now the key to finishing this off and getting the other 5 trig functions. That would be cotangent, cosine, secant, sine, and cosecant is you need to know your ratios. Okay, if you want to pause at this point to reference what those ratios are, go ahead and do that. If you want to give them a shot without them, what I'm really getting at is this thing right here. Okay, very important to know that the tangent ratio is y over x. Okay. Likewise, cotangent is x over y. Cosine is x over r. Secant is r over x. Sine is y over r. And cosecant is r over y. Okay? On our test, this is not information that you're going to have, so it's very important that you know this. Okay, very important. Once I have all that set up, and if you know your trig functions, really not a whole lot to it for this problem. Okay, x is -4, y is 3, there's your cotangent value. Okay, and worth noting, I didn't even need to find r. I could have just taken the reciprocal and flipped the tangent value, which I can always do to get cotangent. Cosine, x, which is -4, r, which is 5. Secant, flip that, r over x. Okay, there's another example. If I just flip it, it would be 5 over -4, but you'll often see that written as -5 over 4. Sine is 3 over 5. Cosecant is the reciprocal, 5 over 3. Okay? Numbers can get a little bit trickier because this value for r could end up being a radical, like the square root of something. Now, this is the first example we've seen where we're finding all 5 trig functions, so I tried to keep the numbers fairly straightforward, but that's how these problems would look. You take them on in a very similar manner. There's really 2 components. You got to know x, y, and r, and then you got to know your ratios for each of the trig functions. If you can handle those 2 things, you should be fine on these kind of problems. Okay, we will call it quits there. On the review for Chapter 7, expect to see a few more problems looking just like this. So if you had any issues with this one, next time we see each other in class, let's talk more.